Okay guys, this calculus lesson is on the derivative of the exponential function e to the x. Let's go ahead and let's do some algebra 2 skills first, you guys. Solve this. 7 equals e to the x plus 1. Okay, on this one I'm going to natural log both sides because natural log is base e. So natural log of 7 equals natural log of e to the x plus 1. And when I teach algebra 2, I call it my blah blah rule, you guys. If these bases match up, then whatever the exponent is, it equals this exponent right here. So natural log is base e. There's a little imaginary little e right here. So these e's would match up. So this exponent, whatever this exponent is, that's what this is. I call it the blah blah rule. So over here I'm going to use the blah blah rule. The natural log of e to the x plus 1 just equals blah blah, the x plus 1. Okay, and then subtract 1 from both sides and you get x equals -1 plus the natural log of 7. Okay, nice and easy. Remember that in algebra 2? Alright, okay, let's do this one. This time the natural log of 2x minus 3 equals 5. I'm going to use this blah blah rule. I'm going to raise both sides to the e power because e to the exponent natural log of blah blah just equals that blah blah. So I'm going to raise both sides to the, or e to the both sides power. How's that? Okay. So now I'm going to use the blah blah rule. This 2x minus 3 is what comes out right here. So 2x minus 3. So I'm going to add 3 to both sides and then divide by 2. And you get x equals e to the 5th plus 3 all over 2. Okay, remember doing that in algebra 2? All right, so let's examine the graphs of y equal the natural log of x versus y equals e to the x. And they're inverses of each other. So I'm going to show you the graph of the line y equals x also. Okay, this is just from, you plug them in your graphing calculators. Here's y equals e to the x. Now this doesn't touch the x-axis down here. It asymptotically gets close, and it'll never touch. It'll infinitely get close. So this graph kind of looks like it is, but it shouldn't be. It should be asymptotically getting close. And similarly, this natural log is asymptotically getting close here. Okay, so can you see that the domain is your x values? Your domain goes to the left forever, so x would be negative infinity to, and it goes to the right forever, to positive infinity. The range is your up and down movement. The range of this function is, it's above 0, so it's 0 all the way up to positive infinity. So here's the facts on e to the x, you guys. Your domain goes from negative infinity to positive infinity. Your range is 0 to infinity. And then don't forget, anything to the 0 power equals 1. So here's e to the 0 power right here, okay, where x equals 0. Okay, so this is y equals e to the x, and so it's equal to 1 right there. All right, and then facts on this one is the domain is left and right, so it starts at 0 and goes to the right forever. So your domain is 0 to infinity. Your range is negative infinity to positive infinity. And then the natural log of 1 equals 0. Here it is right here. Then when x equals 1, the natural log of 1 equals 0. Okay, remember this base right here to this power over here equals this. So e to the 0 equals 1. All right. All right, so the derivative of e to the u is just itself times its chain right there. So it's just e to the u times the chain right there. All right, let's try some of these. All right, so find the derivative of each. Y equals e to the 2x. So it's going to be itself times the chain. So the chain is 2, so it's 2e to the 2x. Okay, let's try e to the x squared. Itself times the chain. Okay, so it's, this time it's 2x e to the x squared. Okay, here's itself right here. Here's the chain. Okay, itself times the chain. All right, let's try this one here. Okay, here I have x e to the power -3 over x. So this is a product rule. I'm going to do the product rule and do the derivative of the first times the second plus the first times the derivative of the second. Okay, the derivative of x is just 1. And then over here I did the derivative over here. Right here, so it's itself, there's itself times the chain, and I did the chain over here, you guys. If y equals the chain, which is -3 over x, which is -3x to the -1, then the power comes down, you decrease it, it becomes positive 3x to the -2, so there's the chain right there. All right, what I'm going to do now is pull, I'm going to GCF out the e to the -3, I'm sorry, e to the power -3 over x. I'm going to GCF that out, and I'm going to be left with 1 plus, and this x is going to cancel out one of these x's right there. So 1 plus 3 over x. Okay, see what I did? All right, and then I have something else. Oh yeah, find the relative extrema of y equals x e to the x. So relative extrema means take the derivative. So we're going to go ahead and take the derivative. And I did product rule right there. Then the relative extrema says we set it equal to 0 and find the criticals. And I find e to the x will never equal 0. Okay, but 1 plus x equals 0 at -1 right there. So we're going to test -1 into y prime, which is this function right here. So when I plug in -1, I'll plug in 0 right here, plug in 0 right there and right there. I get this side to be negative. And then, actually, no, that's positive. Sorry, this is positive right there. When I plug in 0 right there, I made a mistake. This one's going to be positive right here because e to the 0 is, so I'm going to have a mistake on here. You're just going to have to listen to my answer. E to the 0 is 1, and this is 0 right here. I'm sorry, I'm still good. I was thinking positive 1. My bad. This is correct, you guys. So this is a relative. Sorry about that. I don't want to redo this video, you guys. My wife's coming home, and we're going to have dinner, so I don't have time to redo it. So anyway, there's my relative extrema at -1 comma -1 over e. And you plug in -1 back up into this function right here to get your y coordinate right there. All right, easy enough. If you're in my calculus class, this would be your homework assignment. Okay, EOO means every other odd. All right, take care, you guys.